All right, so today we're going to be looking at electron geometries and molecular shapes. So starting off with, um, you have a chart that kind of goes through some things. Um, this is going to look at essentially both electron geometries and molecular shape. So really what it is, first thing we need to do is we need to figure out how many electron pairs or how many electron groups we're working with. And then we go through and we figure out how many electron pairs it has, okay, or how many lone pairs it has outside of that. So really, that's what we're looking at here. So an electron pair or an electron group is any a group of bonds, a bond, I should say, whether it's a single, a double, or a triple bond, that counts as one electron group. And then any lone pairs that our middle atom has, those are considered electron groups as well. And we're going to use this just to make sure that we kind of know how this works. Most of these words should be the same it's what we have on our sheet, but we'll kind of work with that later on. So let me zoom in about right yonder, I think would be good. All right, so starting off with, I'm going to look at this oxygen, this water molecule right here, H2O. So the two things we're going to look for are going to be electron geometry, essentially kind of what shape do the electron groups have, and then what's the molecular shape. If I'm only looking at like the atoms themselves, what shape do we have? So the first thing we need to do here is we need to figure out what is our central atom. Essentially, what is everything look bonded to here? So here I'm looking at, looks like everything's bonded to this oxygen. And for this oxygen, now I need to figure out how many electron groups it has. So I'm just going to circle them. I have a pair of electrons there, so that's one. Pair of electrons there, that's two. I have a bond to a hydrogen here, that's three. Bond to a hydrogen here, that's four. So I have four electron groups, which over here, all right, I'm going to have to pull. Number of electron groups is over here on the far left side. So it turns out I was already right. Start here at 4. So that means that my electron geometry is tetrahedral. Essentially, if I look at the shape these electrons kind of form, it's going to form this tetrahedral shape. So for electron geometry, I'm going to put tetrahedral. Essentially, this thing exists in 3 dimensions where the oxygen's kind of in the middle. I have a pair of electrons that come straight up, and these things are all pushing against each other. Like the electron pairs and these bonded atoms are trying to be as far apart as they possibly could be. This electron's kind of coming down here, kind of come off the side. We'll say this hydrogen's kind of coming right out at us. So I'm going to make that nice, big, and bold to look like it's coming out of the screen. This hydrogen right here, though, that group, that's kind of going back, kind of like it's the third leg, kind of on a like a tripod, essentially. Essentially, this thing makes what looks like a pyramid, is really what it comes down to it. All right, for the molecular shape, though, we're only looking at essentially the nuclei themselves. Okay, so if I come back here, so I know I'm at 4 electron groups. Out of those 4 electron groups, two of them are lone pairs. So I need 4 electron groups, 2 lone pairs. Here's my 4 electron groups. My 2 lone pairs are here. My molecular shape in this case is bent or angular. I typically will use bent for this. So molecular shape is bent. And if I just look at the nuclei of these atoms, oxygen's there, and then my hydrogens are coming off of the side here. Like that shape right there is definitely bent. And then this chart here also gives me the bond angle, which is kind of important. All right, that takes care of water. That takes care of H2O. Draw a line there. All right, so now I'm going to work with HCN. So essentially I have a hydrogen bonded to a carbon that's triple bonded to a nitrogen. All right, first step, figure out what's kind of my central atom that I'm looking at here. Uh, hydrogen's bonded to the carbon, nitrogen's bonded to the carbon. Carbon's my middle atom. Now I need to go through and figure out how many electron groups I have. Carbon has no electron pairs to worry about. So it's going to have 1 electron group here. And then this right here, even though it's a triple bond to a nitrogen, we have 3 bonds here. That's still only 1 electron group. So I have 2 electron groups here. So we got electron geometry, molecular shape. So electron geometry we said was 2 electrons. So 2, 1, 2 electron groups here. Starting off with, so my geometry is going to be linear. And then once again, we said that there were no lone pairs of electrons on there, so my molecular shape will be the same. So in this case, they're both linear. There's no bend, there's no angle here. Essentially, I have an H, kind of an H atom bonded to a carbon, bonded to a nitrogen, and they all form a straight line, is really what we're getting at with that linear shape. All right, so coming over here, this last one, NOCl, nitrogen, oxygen, chlorine. Double bonds between the oxygen and the nitrogen, single bond between the nitrogen and the chlorine. So going through here, it looks like everything bonded to the nitrogen. Nitrogen has one lone pair of electrons. It's bonded to the oxygen, which is an electron group, bonded to the chlorine, which is a third electron group. So I'm looking at 1, 2, 3 electron groups. One of them is a lone pair. All right. So I need to find 3 electron groups, 1 lone pair. So I'm going to be looking at this column. Looks like 3 electron groups, 1 lone pair. So in this case, my electron geometry is going to be trigonal planar. The handout you guys have is way better for this than the molecular. So this is always what your electron geometry is. It's always just going to be what's in that first column. The molecular shape, though, is going to be over here. That'll be bent, essentially. That pair of electrons kind of pushes the oxygen and the chlorines down to kind of form this angle here. This will be less than 120 degrees, though. All right, so where things are going to get tricky is if we have S3P2 trisulfur difluor phosphide. Really what we would have here is, let's go phosphorus, single bond to a sulfur, phosphorus. Keep in mind, I'm kind of making this one up. I don't know if this thing really exists out in nature, but we're going to try it. So let's say you have a molecule, like you do in your homework, that looks something like that. So now your first question is, well, what's my central atom? Essentially, I have 3 central atoms. I have these 2 phosphoruses, which are kind of in the middle, and I have this sulfur as well. In this case, I would say if we just number things, like I would say the 2 phosphoruses look the exact same. So I'm going to put a little 1 next to them. The sulfur is kind of up by itself, so I'm going to put 2 there. So now I'm going to have an electron geometry for my 2 phosphoruses. I'm going to have molecular shapes for those 2 phosphoruses. And then the same thing is true for my central sulfur here. So that's going to have an electron geometry. And it's going to have an electron shape. I would say let's start with sulfur. We have 1, 2, 3, 4 electron groups, 2 of which are lone pairs. So I need 4 and then 2 here. Let me do that a little bit. All right, so that is the opposite of what I wanted. There. All right, so looking at the sulfur, the electron geometry is this one right here. It's tetrahedral. What we're going to find is so long as it's observing the octet rule, the electron geometry a lot of the times will be tetrahedral. Not always, but a lot of times. The molecular shape. So we said we had 2 lone pairs here, so that's 0 lone pairs, 1 lone pair, 2 lone pairs. That's bent. And even when we're looking at this, we can kind of see the molecular geometry here would be bent. We have the electrons on one side, forcing the phosphoruses down on the other side. All right, let's come up and look at the phosphoruses here. Phosphorusi, maybe? All right, so in any case, so electron geometry time. So if I'm just going to look at this one phosphorus. They both look the same, but just looking at this one, for electron geometries, I have 1 lone pair, and then 2 different sulfurs I'm bonded to, so 1, 2, 3, okay? So I'm at 3 electron groups, 1 lone pair. So first thing first, here's my 3 electron groups. My electron geometry will be trigonal planar. And in my molecular shape, I have one lone pair, so let's just jump over here. That's going to be bent as well. And so even with the way I drew this, which granted I have some, prior knowledge to pull from, I can even see, the pair of electrons is here and it's kind of pushing these sulfurs away too. Really, that's how you do electron geometry and molecular shape. You're essentially just have to use that handout we gave, identify how many bonded atoms you have, how many electron pairs you have, how many electron groups you have, and then just kind of follow the chart. Other than that, good luck and have fun with the practice.